Alright, you've made it to Unit 7, and after the grueling Unit 6, we're actually going to do some applications of integration. And our first one in Lesson 7.1 will be solving differential equations, and also verifying some solutions. Now, you've seen differential equations before, you know that? Well, differential equations are just equations with derivatives in them. So, you've seen them before, because here's an equation with a derivative in them. Okay? But in this course, we will only learn how to solve the simplest type, not really this type, but differential equations like this, where I involve both x and y's together with the derivatives. Okay? The method we're going to use is called separating variables. Yes, this is the most basic type, because when you get to university, there's actually a whole course and a whole branch of math called differential equations. Yes. So, for us, we're just learning the basics of it. And the idea is you may be asked to find what they call a general solution. So if you think about our previous examples like this, if y prime equals to 3x squared, then y equals to, of course, equals to x cubed plus c. That would be the general solution, because we have a family of curves. Or a particular solution, and remember how we did that for this one? Yeah, we had to plug in some initial condition. So that same kind of idea will exist here. And when we do that, you'll get not a family of curves, but one specific curve. Now, there is a nice procedure for doing this, and here it is, so you can read through this yourself. I'd prefer, instead of having y prime, you write things now as dy dx, because when you try to separate the equations, we'll try to separate the y's with the y's and the x with the x's. Similarly with the dy and dx, those are two separate things. Once again, separating the variables is the most critical step. And then after we do that, we have to integrate both sides, because of course we don't want to have differential equation anymore. We want to have the original equation. And then we will solve for y. Okay? So I know it's kind of fuzzy with these procedures, but let's go ahead and actually do a question. Alright? So here example number 1. It says find the general solution, so that's the thing with plus c, okay? Of this equation, x plus 2y times y prime equaling 0. Okay? Now once again, I don't like the use of y prime. Let's rewrite it as dy dx. Good. And now our goal is to isolate the variables. Okay? Separate the y's on one side, separate the x's on the other. I like to keep the y's on the left side as much as possible. So that means I'm going to move that x to the right hand side. Remember, dy dx, okay, that's a ratio, so I can separate that, and I can move the dx now to the right-hand side. So 2y dy equals to negative x dx. Alright? So right now, I've completed the process of separating the variables. Okay? So the idea is to, first of all, separate variables. Once that is done, remember how I said earlier, we now need to integrate both sides of the equation. So now I'm going to actually ask you to integrate or anti-differentiate both sides separately. So what is the integral of 2y dy? Yes, that's just y squared. What is the integral of negative x? Yes, integrate, add 1 to the exponent, divide by the new exponent. I'll just put a hat in front. Now, you might be thinking, what about that plus c? Good point. I guess I should have a plus c here and a plus c here, but wait, did those plus c cancel each other out then? No. They are different possible constants. And to avoid confusion, let's just combine them together as one constant, and I always like to put it on the right-hand side with the x. Alright? So just one of these, please. Alright? Now, this is good. Okay? Y squared equals to negative 1/2 x squared plus c. But usually you want to solve for y. Okay? So, wait, I should go back. Separated variables, yes, this step was integrate both sides. Okay? Both sides separately. And then don't forget plus c. Don't forget. Now, once again, we want to solve for y, not y squared, right? So, how do I do that? Well, I should take the square root. And when I take the square root, don't forget, I have a plus or a minus in front. So, writing my solution to example 1 as a pair of possible functions in this form for the particular solutions to the differential equation, meaning I want you to separate this, okay, because I want functions. Notice that if I have the plus or minus, you'll see if you visually graph this out, you get actually, one side up here, one side down there. That's a problem because it's not a function. It doesn't pass the vertical line test. So we need to separate them as two possible answers. So y equals to the positive root, or y equals to the negative root. Okay. Now, once again, why are we writing them separately? Well, I'm going to put a little note here. Okay. They are written separately, so the solutions are written separately. Why? Because the solution is either one or the other. But not both. Okay? Remember, we want functions. They need to be functions. Need to be functions. Okay. Alright. Now, let's see how we could do example number 2 then. Okay. So, this one says find an equation of a function. Okay, once again, a function. But this one gives me more information. It contains a particular point. It's like doing those previous questions where we had to find an initial condition and they gave it to you so you can plug it in and solve for C. That's what I want to do here. Okay? It says here whose slope, hint hint hint, slope, hint hint hint, dy dx, hint hint hint, differential equation, right, is equal to x e to the x squared divided by y. So let me ask you to write this down first. Dy dx is equal to x e to the power of x squared over y. Okay? And our goal here right now is to solve for y. So we'll go through the same process. What's the process again? Let's separate the variables. I'm going to ask you to bring the y's to one side and the x's to the other side. So y times dy on the left hand side, x times e to the x squared dx on the right hand side. Good. Once you separate the variables, you got it. It's time to integrate. Integrating y dy, not a problem. We'll add 1 to the exponent. We'll divide by the new exponent. Integrating the right side. Oh, maybe not so fun here. Uh-oh. Up to you how you want to do this. X times e to the x squared. I'm going to try to do this using, should I use reverse chain rule or use substitution? Doesn't really matter to me. It might matter to you, but I'm going to do the easy one because I'm thinking, this is like my u. So I want to find something in the expression that has the derivative of x squared. The derivative of x squared probably is 2x. So, ooh, I have an x, that's great, but I need a 2. Right, so I'm going to put the 2 in front, which means I also need a 1/2 to balance it out. This is the reverse chain rule method, remember? And that allows me to then say, hey, when I take the integral, this just disappears. So I get 1/2, and the integral of e to the blah 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 is just e to the blah blah blah, so 1/2 e to the x squared. And then I'm going to put my constant plus c. Good. Okay. Once again, if you don't like that reverse chain rule, u substitution works. Okay, so if you use u substitution, I would have let u equals to x squared, du dx equals to 2x, solve for dx, and you should have got the same thing. Okay? Alright, back to here. So we've solved, we've got this plus c, And now, just like before, we want to solve for y, so we can actually solve for y. Ooh, I don't like that division by 2. I'm just going to make it a little bit nicer by multiplying every single term by 2. Now, if you think about it, this becomes 2 times c. Now, think about what that means. A constant times 2 is still going to be a constant. But of course, it's a different constant. So, a lot of math teachers and books will just use a different notation for c, like c sub 1. Or if you don't like that, you can use d, whatever you wish. Okay, I'm just going to use c sub 1 in this case, just to show that this constant is different than the constant here, c in black. But nonetheless, it's just trying to solve for that variable, or that, yeah, that constant anyways, in the end. Okay, our goal once again is to solve for y. So I'm going to take y, take the square root, plus or minus. Okay, and now remember, I'm looking for a function, so I either need the positive or the negative one. Which one should I actually use in this particular case? If you're not too sure, think back to this idea right here in the equation. It contains this point. So it contains the point 0, negative 3. Which one should I use? If you said, please use the negative one, I am very happy. Why is that the case? Because now if I plug in the point, negative 3 equals to negative square root of e to the 0 squared plus c sub 1, I should now be able to solve for c sub 1. If I didn't use this this negative square root function, notice that I would have had big issues here because I would have had a positive root equaling a negative answer. That would be a problem. So thankfully, choosing the negative choice of the function allows me to then quickly solve this. 3 equals to e to the 0 is just 1, and then I can just quickly go ahead and square both sides, and then, oops, don't need to square it anymore, square both sides, and then you can solve and say, hey, c sub 1 equals to 8, and therefore my equation is y equals to negative the square root of e to the x squared plus 8. Beautiful. Okay. Now just a few kind of notes here on this example. And I did leave some space here. I hope you still have some space. So just a few notes. Okay, actually notes. Yeah, notes. Why did we choose first of all that negative square root again? Well, once again, it was because of that point. The initial y value was negative. So I want to make that point as well here. Okay, so the negative square root was chosen because the initial point given the y value of it was negative. Okay, so that's why I chose the negative one right here. Negative. Okay. Don't worry about this c and c sub 1 business here, okay? I know I made it like that because I think it's more clear, but just to be aware, on the AP exam, there really is no penalty on the AP test if no distinction is made between our constant c or c sub 1 or anything else, okay? Now, we decided to solve for c sub 1 at the end, but you didn't actually have to do that, okay? So my third note here is you don't really need to solve for c at the end, okay? You could have, so I'll say you don't need to solve for c at the end, okay? The end. What could you have done instead? Well, you could have solved it first before solving for y. Okay, so you can also solve for c first before solving for y. And let me just show you how we can do that right now, because I have a little bit of space here. Apologies if this is a little bit messy, but I think it's important to do. You see this equation here that I'm going to circle in green? Okay. I could have actually just used that equation and solved for c1 right away. Yeah, think about it. Y squared, right? Negative 3 squared equals to e to the 0 squared plus c1. 9 equals to 1 plus c1. Yeah, c1 equals to 8. I could have solved it here first and then just used 8 and carried it out through to my final answer. Okay? So it really doesn't matter when you solve for c. If you prefer doing it before solving for y, go right ahead. It doesn't make a difference. Okay. Alright. How are you feeling? Well, I really can't help you if you're feeling bad, but I hope you're not. So let's move on to example number 3. Okay? I'd like to see if you can now do this yourself. Alright? Because I think I've shown you all the steps, and it's always good that you try. I know listening to me is great, but you really need to practice on your own. Okay? So press pause, try it. If you do get stuck, then of course come back and then play the video so you can see the answer done. Alright? Go for it, please. Now you might be thinking, this is kind of weird. The x's are on one side, so why don't I just move the dy to this side? That is a problem. If you did that, and don't write this down, or if you did that, erase it now. Here's your issue. You have your dx and dy in the denominator. That is a problem. It's supposed to be in the numerator because you can't really integrate like this with the dx and dy in the denominator. Okay? So that is no. So, once again, I would ask you to isolate the y's on one side and the x's on the other. So, if you did do this, okay, you have to keep going. And I would now take the y minus 2 and put it on the side, and take the x and put it on the left side. So you have the following: dx over x equals to dy over y minus 2. Okay, now if that doesn't float your boat, then I'm going to write this as 1 over x dx equals to 1 over y minus 2 dy. And I think now this will help you integrate. What function do I get when I get the integral of 1 over x? That's correct. Our good old natural log of x. Don't forget the absolute value. I'm going to put the plus c on the x side. And then over here, the natural log of the absolute value of y minus 2. Good. Okay. Alright, now we can continue to try to find the general solution. Okay. Especially if I asked you to solve for y, but if I didn't, you can leave it from here and move on to part B. But I think for me, right now, I am going to try to solve for y. Okay. And then the question is, how do I now solve for y? So to solve for y, we need to eliminate the ln. Then we eliminate ln by taking, that's right, e to the power of it on both sides. So watch please. E to the ln of the absolute value of x plus c, that plus c is part of the exponent, is equal to e to the natural log of y minus 2. Now, when we do this, let's do the right hand side first. E and natural log, they are inverse functions, so we're just left with, that's right, the absolute value of y minus 2. However, for the right hand side, be careful. You cannot just eliminate and say this is equal to the absolute value of x plus c. No. Okay? What you need to realize, is that this is a power with base e, and you have two exponents added together, which means you have to separate them. Remember your exponential rules? X to the power a times x to the power b equals x to the power a plus b. Remember that? So I'm just reversing it here. And notice that e to the c is just another constant. I'm going to call that my c sub 1 now. And then e to the natural log of x, yes, that does simplify to the absolute value of x. Okay? So now you have this, and you're like, oh, what about those absolute values? Good point. Okay? So when I take off those absolute values, really I have a plus or minus. So if I were to, and just watch for a sec, if I were to remove the absolute value, really I have a plus or minus here, I have a plus or minus in terms of the x, and I'm multiplying this by c sub 1. So forget all these plus or minuses, that's just really confusing. Let us all just combine those plus or minuses into my constant. So really I'm saying I will make this y minus 2, I'll make that regular x, I'm just going to put a plus minus in front of the c sub 1. Well, that c sub 1 is just another constant, right? Plus or minus c sub 1 is another constant. So I could just rewrite this as another constant. I'll call that c sub 2x. And that equals to y minus 2. Or, better yet, to solve for y is equal to c sub 2x, so a constant times x, plus 2. Or if you like to write it like this, that's okay as well. Okay, there's my general solution. Okay. Now once again, for my particular solution, I have two choices. I can actually go ahead and find the particular solution now using this form, which I think is pretty easy. So continuing on now, continuation for part B. I know that y of 1 equals to a half, so a half is y, x is 1. We'll try to solve here. This becomes, I think, negative 3 over 2. So therefore my particular solution is y equals to negative 3 over 2x plus 2. And that's perfectly fine. Okay? But remember how I said you didn't have to solve for y first? So the other method could have been doing it from this particular step. Okay? So let me call this method number 2, okay, or alternate method. This would be, let's not solve for y first. Let's go ahead and actually plug in the numbers and calculate what the constant is first, and then go back and solve for y. Okay, we can do that. So if I did it like this, then the natural log of, I think, 1 plus c equals the natural log of 1/2 minus 2. So natural log of 1, of course, is 0, so I'm just left with c. So c equals to the natural log of 1/2 minus 2 is negative 3 over 2, but it's the absolute value, so just ln of 3 over 2. Okay. And then, of course, knowing this, I can plug it back in now. So natural log of the absolute value of x plus natural log 3 over 2 equals to natural log of the absolute value of y minus 2. And then I will solve for it by taking e on both sides. Okay. Now remember what happens when I do that with these natural logs. Oops, don't need that. That was the last video. Okay. What do we get here? Well, hopefully you will see that this is e to the power of something plus something. So yes, we can separate them into e natural log of absolute value of x times e natural log of 3 over 2. And then over here we get what? Y minus 2. Okay. Now, here there's a quick note I need to actually explain. Please note, write this down when doing this alternate method. Please note that y minus 2 is actually negative, right? Because this was really a negative number. So because y minus 2 was actually a negative number, we need to put a negative in front of this expression. Okay, so that's the only tricky part about this particular method. Alright, and when you do that, okay, we have here negative, once again, the absolute value of x. We don't have to worry about that, that's just x then. And then we have e to the ln 3 over 2, that's just times 3 over 2, and that equals to y minus 2. And now, hopefully you can see that we have the exact same expression as what we had from the other method. Okay? So once again, remember that absolute value of x, right? The key thing is, since y minus 2 is negative, we need that negative sign there. Okay, now the last part of this lesson is talking about verifying equations. And you've done this before, right? If I gave you an algebraic equation like this, yes, you might not be able to solve algebraically, but you could actually answer this question. Is x equal to negative 2 a solution? How would you do that? Well, you just plug it in and see if the right side is equal to 0. Yeah, so if we plug it in, we'll cross our fingers. Negative 2 to the power of 3 plus negative 2 squared plus 4. That is negative 8 plus 4 plus 4. Oh, look at that. Does this equal to 0? Does this equal to 0? It does. So therefore, yes, x equals negative 2 must be a solution. Yeah. So then if I ask you a question like this, is y equals to 1/2 e to the x plus e to the negative x a solution to this differential equation? Now, notice in this case, if you want to solve just like the previous method of separating the variables, you can try, by the way, don't write this down right now, just watch, you can try, okay, you can try, no, not okay, because there's a dx multiplied here. Problem. So you cannot actually solve this equation using the separating differentiable method. And that's why they're just asking you, is this a solution? So just like how you did number 4 by plugging in the x value and evaluating, that's what I need you to do here for example 5 as well. Plug in the y, and in this case you also need y prime, so let's calculate that first of all. What's y prime? Oh, it's e to the x function. Perfect. That's the derivative of itself. It's just e to the x. The derivative of e to the negative x is itself, but of course with an extra factor of negative 1. So I'll just write this a little bit nicer. Minus e to the negative x. So here is y prime. So I want you to plug this into y prime, and I want you to plug this into wherever you see y. And the question now is, does the left side then equal to the right side? Well, we know that the left side here, left side, is just 1/2 e to the x minus e to the negative x. Okay, so now the question is, what's the right side? Well, that's e to the x minus y, and y is this function 1/2 e to the x plus e to the negative x. Well, let's distribute the minus sign and cross our fingers. E to the x minus 1/2 e to the x minus e to the negative x. These first two terms, yeah, they simplify to 1/2 e to the x minus e to the negative x. And lo and behold, da-da-da, they are the same. So yes, the left side does equal to the right side. So yes, okay, y equals to 1/2 e to the x plus e to the negative x is a solution to that differential equation. Okay? Alright, that's it for our first lesson in Unit 7. Come back for more in Lesson 7.2. Let's go do some practice.